On the Algebra Refresher worksheet, on the back side, number 27. So graphing y equals 2x squared minus 8x plus 4. First, let's find these different characteristics. In order to find the vertex, we need to know the axis of symmetry. And so if we use the quadratic formula, the negative b over 2a tells us the axis of symmetry. So if a equals 2 and b equals negative 8 and c equals 4, then negative b over 2a, so the opposite of negative 8 divided by 2 times 2 will give us 8 over 4, which is equal to 2. So that was negative b over 2a. So the axis of symmetry is x equals 2. It must be an equation because it is a line. Then the vertex, the axis of symmetry goes through the vertex, so the x-coordinate will be 2, but now we have to put 2 into the equation in order to figure out the y value. So if we take 2 and then instead of x we're going to insert 2 for x. So 2 times 2 squared minus 8 times 2 plus 4. 2 times 4 is 8 minus 16 plus 4 equals negative 4. So because the a value is positive, that means that this graph is going to open up. So if I find 2, negative 4, plot the vertex, it opens up. The a value is 2, which means that when we go over 1, we're going to be going up 2 units. Over 1, up 2 units. And then let's see, the next one, the y-intercept comes from the c value, because if you put 0 in for x, the first two terms drop out and we just have 4. So 0, 4 is the y-intercept. And so when we went over 2, we're going up 8. Over 2, up 8. So that gives us the graph. Try to make it rounded through the bottom. And so this graph has a lowest point, a minimum. So we'll circle minimum. And the minimum value is how far down, how far down is that minimum value. And so we look at the y-coordinate, and since the y-coordinate of the vertex is negative 4, the value of that minimum is negative 4. The domain of every quadratic equation is all real numbers. The range, I'll write that out, all real numbers. The range is what's the lowest point on the graph. So the graph goes down to negative 4. So in interval notation, we start with negative 4 as the lowest point. We use a bracket with negative 4. And then the highest point, this keeps going up and up and up, so the highest point is infinity. And we use parentheses with infinity. So you can write in that form, or if you just want to write an inequality, the y-coordinate needs to be greater than or equal to negative 4. Either form is okay. Number 28. This one is in vertex form. Y equals a times x minus h squared plus k. So the vertex comes from the h and the k. So plus 3 is the same as x minus negative 3. So the h value is negative 3. The k value is negative 5. the axis of symmetry always goes through the vertex. So it's going to be x equals the x coordinate, -3. Because the a value is negative, a -1, that means that this graph is actually going to open down. So at -3, -5, it's going to be opening down. So it has a highest point on the graph, a maximum, and its value is the y-coordinate of the vertex, -5. The y-intercept, to find y-intercept, we have to put 0 in for x. So we take our equation and we're going to insert 0 for x and solve for y. So 0 plus 3 is 3, 3 squared is 9, so -9 minus 5 equals -14. The y-intercept is at -14. And because it's opening down, we expect it to be down here around -14. Domain, all real numbers. Range, well, the lowest point on the graph, these keep going down, so the lowest point is -infinity. The highest point, the y-coordinate of the vertex, is -5 with a bracket. So as an inequality, y has to be less than or equal to -5. Either form would be okay. Factoring. So the first thing with factoring is we always look for a greatest common factor, the GCF. 16 and 25, there's nothing that goes into both of them. So the next thing is we see that there's two terms that are being subtracted. So I want to look for the difference of squares. What squared equals 16x squared? 4 times 4 is 16, x times x is x squared. Same thing with 25. What squared equals 25? 5 times 5 is 25. And so the factored form takes the 4x and the 5, and it combines them once with addition, 4x plus 5, and once with subtraction, 4x minus 5. That is factored form. Number 30. First thing, look for a greatest common factor, but 5, 13, and 6, there's nothing that divides evenly into each of those. So the next step is, I see that there's 3 terms, and so we have to use the x box approach. So we make our x, the first term times the last term, 5 times -6, gives me the top of the x. The middle term, 13, goes in the bottom. I'm looking for what numbers multiply to get -30 that add to get 13. And so if you need to make a list of different numbers that could work, so 30 I can find by taking 1 times 30, 2 times 15, 3 times 10, 4 doesn't go in, 5 times 6, and then 6 is already on the other side. So I need to multiply to get negative, so one of these numbers has to be negative, but if they're going to add to get a positive, the smaller number has to be the negative number. So which of these pairs adds to get positive 13? -2 and 15. -2 times 15. So the -2 and the 15 is what combine to make 13x. So we keep the 5x squared, and we write these two down, -2x and plus 15x. So they both get an x next to them. Notice when you add them together you get 13x, and then we keep the -6. So now we're factoring by grouping. So we split these up right after the 2x. Look at the first two terms. What's the greatest common factor? 5 and 2 don't have anything, but x squared and x can both have an x in them. So if we pull out the x, we're left with 5x minus 2. Then we look at the last two terms. 15 and 6 can both be divided by 3. It's a positive 15, so I'm going to bring out a positive 3. 15 divided by 3 is 5x. Negative 6 divided by 3 is negative 2. If we did this correctly, 5x minus 2, what's in the parentheses has to be the exact same thing. So 5x minus 2 will be one of the factors, and what's in front of those parentheses, x plus 3, gives me the other factor. (31). As I look at the terms, first thing is look for a greatest common factor. And when I see all these exponents, probably greatest common factor is the only thing I'm looking for. 48, 6, and 18. I notice that 6 goes into all three of those numbers. So I'm going to factor out a 6. Then I look at the variables, x to the third, x squared, and x to the fifth. The smallest exponent is what we want to factor out. So the x squared is the most number of x's they all have. Then I look at the y's, y to the fourth, y, and y to the third. They all have at least one y. And so what's left after you take 6x squared y out of each of these terms? If it helps to think about dividing each of them by 6x squared y, then go ahead and do that. And so 48 divided by 6 leaves me with 8. 6 times 8 is 48. X to the third divided by x squared, there's one more x on top. X squared times x is x to the third. Y to the fourth divided by y, there are 3 more y's on top. Y times y to the third is y to the fourth. Now I keep that minus sign. 6 divided by 6 is 1. X squared divided by x squared is 1. Y divided by y is 1. So 6x squared y divided by 6x squared y is 1. And the third term, 18 divided by 6 is 3. 6 times 3 is 18. X to the fifth divided by x squared is x to the third. Subtract the exponents. X squared times x to the third is x to the fifth. Y to the third divided by y is y squared. Y times y squared is y to the third. And when I see what's left, nothing in there looks factorable. And so this is factored form.